Hi guys, in this video I'm going to teach you how to convert hexadecimal number, which is base 16, to other bases. So we're going to convert hexadecimal to binary, octal, and decimal number. So say for example we are given B2 hexadecimal. How are we going to convert this to binary, octal, and decimal? So first, see to it that the given hexadecimal number is a valid number. So we have B2 that is valid. So to check if it is valid, meaning to say it uses the decimal number 0 to 9 and the letters A to F. So we have B2. Now to convert this to binary, we know that each digit of the hexadecimal number is equivalent to 4 digits of binary numbers. So applying that, how are we going to represent 2 as a 4-digit binary numbers? So considering our positional value, we have 0, 1, 0, 0. Binary equivalent of the hexadecimal digit 2. So if you notice, we have to put the zeros here because the number should be represented using 4 binary digits. Okay, so B is 11. How are we going to convert or to represent B as a binary number using 4 binary digits? So 11 is 1, 0, 1, 1. So we have 1 plus 2 is 3 plus 8, that is 11. So this is actually the B equivalent and this is the 2 equivalent. So this is now our binary equivalent. Since we have already our binary equivalent, we can easily get its octal conversion. So octal means we're going to group it into 3, 1, 2, 3, 1, 2, 3. So using the positional value again, this is 2, this is 2, 4, that is 6, this is 2. So the octal equivalent is 2, 6, 2. Finally, to get its decimal equivalent, we use the given hexadecimal number. So we multiply it by exponent of 16 raised to 0 raised to 1. This is 2. 16 times 11 is 176. So we have 178 decimal equivalent. So let's have another example of converting hexadecimal numbers to binary, octal, and decimal. Say you are given the hexadecimal number 4E5. How are we going to convert this to its binary, octal, and decimal equivalent? So again, we start converting it to binary. So how are we going to represent 5 using a 4-digit binary number? So we have 0, 1, 0, 1. So this is 5. How about E? E is 14. So we have 1, 1, 1, 0. And then 4 is 0, 0, 1. So this is 5. This is E. And this is 4. Okay, so if you notice, you don't anymore put any more 0 if it is on the left side of the numbers. Okay, so we have 4E5. So the binary equivalent of 4E5 is 100, 1110, 0101. Now, out from our binary equivalent, we can easily get the octal conversion. So we simply rewrite the numbers and then we group it into 3. There. Okay, so this is 5, this is 4, this is 3, and this is 2. So the octal equivalent is 2, 3, 4, 5. To get its Decimal equivalent, we are going to use the given number 4e5. Then we multiply it by exponent of 16. We start with 16 raised to 0, 16 raised to 1, and 16 squared. So of course, if you have more than 3 digits, you can still multiply it. Now if you have more than 4 digits, you can use times 16 cube, and then 16 to the 4th power, and so on and so forth. So this is 1 times 5, we have 5. 16 times 14 is 224. And then 16 squared times 4 is 1024. So the decimal equivalent is 1253. So the decimal equivalent is 1253.